Okay, good morning. Yeah, I think it's a good idea if you go through the quiz problems. So the first question that you see here on the board is the simple question. Write the complex number z in this form expressed. We want to write it in a standard form. Yes, that's a very simple question. Yes. So the complex number z is I to the power of 5 multiplied by 1 plus 2i and then minus 1 plus I multiplied by 1 minus I. Okay, so I would consider this a very simple question. So I5, what should I write for I5? What we know about I is just I squared. So I have to write this in terms of I squared. So I would write it as I squared, but to power 2. So far I have I to power 4, but I need I to power 5, so I have to multiply it by an extra I. But I to power 2 is minus 1 to power 2 multiplied by I. Minus 1 to power 2 is 1 times I is just simple. So this I to the power of 5 is nothing except I. So z becomes I multiplied by 1 plus 2i. And then minus 1 plus I, 1 minus I. This is the first thing. Of course, you can do things faster, but I don't want to push you. For the exam, you have to do it patiently. Okay, so this one, no problems. You just multiply I in. Here you can also multiply, but you can also use the conjugate rule. It doesn't matter. If you do it correctly, I will accept it from you. But some of you are careless. You have to be very careful when it comes to quizzes or exams. If I want to open it up, according to the conjugate rule, it becomes the first one squared minus the second one squared. Yes? But minus I, so I squared is minus 1. There is a minus sign here, so it becomes plus 1. And 1 to power 2 is 1. So this is nothing except 2. Okay? And then I multiply this this I in, so this becomes I times 1 plus 2i squared. But what is 2i squared again? I squared is minus 1, 2i squared is minus 2. And then I have a minus 2. So the answer is I minus 4, if you write this correct, but I prefer, because I have mentioned to write it as A plus BI4, I want you to write the real part first, but it doesn't matter. If I want to write the real part first, I write minus 4 first, and then I would write plus I. Okay, so it doesn't matter. Even if you have written this one, you will get the points, but this is what I meant. Is that right? So it was very simple problem, okay? Now let us go to the next problem. We have this equation, 2 plus z bar equals to 5 plus 4i. We are supposed to find z and write it here. We are also supposed to find real part of z minus imaginary part of z. Yes? So how can I solve this problem? So I would say that the problem is 2 plus z bar equals to 5 plus 4i. You know that you need to find z. If I can manage to find z bar, I can find z, yes? So it's very simple. You just move 2 to the other side. So what happens for z bar? 5 plus 4i, 2 goes to the other side. Let me write it. But 5 minus 2 is 3 plus 4i. But be careful, this is z bar. The question wants z. So what is z? You know that this will not change. This will be minus. That's the answer. Okay? And then if I ask you what is the real part of z, because the question mark is real part minus imaginary part as well. So what is the real part? This number is the real part. Minus, what is the imaginary part? Is minus 4. So it becomes 3 plus 4, which is, that's also simple. So these first 3 questions are extremely simple, so you should be able to do it very fast. Okay, if z is given to be this complex number, then 3 times real part of z plus imaginary part of z, you have to calculate and write it here. But that's also very standard. This is a fraction, and I told you that because addition, subtraction, and multiplication are very straightforward in complex numbers, but when it comes to division, you have to remember one thing. What is that thing? To rescale it by the conjugate of the denominator. And then, of course, if you do the calculations, you can read the information you need there. So let me go to the board. So what is the other problem? So z is given to be what? 2 plus 4i divided by 3 minus I. Okay, the question mark is 3 times the real part of z plus the imaginary part of z. This is what is wanted. But you know that you cannot read the real part and imaginary part if the complex number is not in the standard form. So it motivates you to do it, to write it in a standard form first. And then you have to remember something from the lesson, and that is to rescale by the conjugate of the denominator. So the conjugate of the denominator is 3 plus I, 3 plus I. So you have to multiply the numerator and denominator simultaneously by this combination. And then you have two multiplication problems, yes? I multiply this by that, by multiplying 2 by 3, 6, multiplying 2 by I, 2i, multiplying 4i by 3, 12i, multiplying 4i by I, 4i squared. And then here, you can multiply, but better to use the conjugate rule. So the conjugate rule becomes the first one to power 2 minus the second one to power 2. And then simplify. So what is 4i squared? I squared is minus 1, so it becomes minus 4. Minus 4 and 6 becomes 2. So it becomes 2 plus 12 becomes 14i. And what about the denominator? This one is just simply 9. This one is minus 1. 9 minus minus 1 is 10. So it becomes 10. But be careful, this is not still in a standard form. So I would write 2 over 10 plus 14 over 10i. And I simplify it. So it is 1 over 5 plus 7 over 5i. Yes? So this is my complex number. But what is my question mark? Question mark is equal to 3 times the real part. This is your real part. If I multiply it by 3, it becomes 3/5. Plus the imaginary part, which is 7 over 5. But this becomes 10 over 5. So the question mark is simply 2. So these are the first 3 questions that you really need to know at this level. And these are E-level questions. Any questions so far? Okay, so let us go to the next problem. Okay, so if 2z plus z bar equals to 3 plus 4i, then I want to calculate imaginary part of z to the power of 2 plus the real part of z to power 2. So these are C-level questions because here both z and z bar are involved, and we had many of these problems during the lesson, and they are also in the book. Okay, so do you remember what was the trick if you want to solve them? So the equation is this: is 2z plus z bar equals to what? 3 plus 4i. And I want to calculate the real part of z to the power of 2 plus imaginary part of z to the power of 2. Okay? So do you remember, if I have an equation in which z and z bar are involved, and if you want to find this, you start with the sentence. Yes, we say that let z be equal to x plus y, I. Okay, and then I also need z bar. So what will be z bar then? Z bar will be x minus yi. And then I take these and put them back into my equation. So this becomes 2 times x plus yi plus z bar x minus yi equals to 3 plus 4i. Okay, and then I simplify. I multiply 2, so it becomes 2x plus 2yi plus x minus yi equals to 3 plus 4i. But x plus 2x is 3x, 2yi minus yi is just simply yi equals to 3 plus 4i. And then we learn that if I have a complex number on the left and I have a complex number on the right and I want to equate them, this can happen if and only if the real parts are the same and the imaginary parts are the same. Yes? But what is this one? This means that x is 1 and y is 4. As simple as that. And the question mark is equal to the real part of z is x. The imaginary part of z is y, and I know them. So this becomes 1 to power 2 plus 4 to power 2, which is 17. And that's the answer to this problem. Okay, so that was also very simple. Okay, so now let us go to the next problem. So the equation x to the power of 3 plus 6x squared plus 3x minus 10 has 3 real roots. This is given you as a piece of information. It is easy to see that x equals to 1 is one of its roots. So I haven't asked you to check it out. Of course, if you want, you can replace x with 1 and to see it works. Yes, 1 plus 6 plus 3 is 10, minus 10 is 0. So that's correct. But I have written in red, yes, I need the product of the other 2 roots of this equation. So it means that you need to find the other 2 roots and then multiply them. Okay? So what we have to do is to do the long division. Do you remember? So that is one of the lessons that we practiced a lot. So when this equation is given to you, when we know this polynomial, x to the power of 3 plus 6x squared plus 3x minus 10, we know that x equals to 1 is one of the roots of this equation. So according to the lesson, it is divisible by x minus 1. So you have to do the long division. Yes, do you remember? We have to draw this line here and then divide this using the long division method by x minus 1. Okay. So you take the first term and divide it by the first. It becomes x squared, and you write x squared on top here. And then you multiply x squared by everything and write them here, but with opposite signs. So x squared times x is x cubed, but you write it with the opposite sign. X squared times minus 1 is minus x squared, but you write it with the opposite. And then you add them up. So when you add them, this one and that one are gone, this one and that one becomes 7x squared, and this one becomes 3x minus 10. I just bring them down. And I repeat the process. According to the problem, because this is divisible by this, you will end up with 0 as the remainder. So you have to continue until you see 0 here. So I will do the process once more. 7x squared by x is 7x plus 7x. I multiply 7x here and there and write them with the opposite signs here. 7x times x, 7x squared. I change the sign, it becomes negative. 7x times minus 1 is minus 7x. I change the sign. And then I add them again. This one and that one are gone. This becomes 10x minus 10. And I do the process once more. 10x divided by x is plus 10. And then I multiply 10, change the sign, and write them here. 10x becomes minus 10x. Minus 10 becomes plus 10. I add them, yes, as predicted, the remainder vanishes. So this means that this long process is finished. This means that using the long division, I was able to factorize my original polynomial, which is, what should I write? My original polynomial is this multiplied by the quotient, because the remainder is 0. So this becomes x minus 1 times x squared plus 7x plus 10. Okay, my goal was to solve this equation. So I want to put this equal to 0 and solve it. But this one is equal to this one. So this means x minus 1 times x squared plus 7x plus 10 equals to 0. This means that either this one is 0, which is not of surprise because x equals to 1 was already given to me an answer. So this is not the other 2 answers. The other two answers are coming from this equation. You can use ABC, PQ formula, or even factorization in your head. It is not hard. Okay? Of course, if you know the rule, the product of the roots is always this number divided by that number. So I already know the answer is 10. If you know this from Ma4, one of the exercises, you can use it. Otherwise, what you do, you find the roots. If you don't mind, let me solve it using factorization. Do you remember? I open two pairs of brackets. Within each one of them, I put an x. I ask myself, are there two numbers? Of course, this is not always recommended here because sometimes the roots are complex, so you might not be able to guess. But because these numbers are so simple, I guessed them. Otherwise, you have to use PQ formula because it might be the answers are complex. It is not easy to guess. But guessing here is simple. I need two numbers whose sum is 7 and the product is 10. What are those numbers? 2 and 5. Yes? So this means one other answer is -2. The other answer is -5. So the roots of the polynomial are 1, -2, -5. 1 was already given from the beginning. The question is asking you about the product of the other two roots. So this means that you have to multiply. So what you have to type in the question mark place is what? -2 times -5, which is 10. Yes? So that was also simple compared to the problems we actually solved in the lesson, yes? Any questions? Okay, let us go to the next problem. That's also very simple. I have given you a complex number, but in the form of the sum of two fractions, and I'm asking you about the imaginary part of this whole complex number. So here you can solve it in two different ways. You can imagine this is one division, solve one division problem. You can imagine this is another division, solve it with the same form, and then add them up. But I prefer to combine them into one problem. That's also possible. But it doesn't matter in which way you do it. If you can do it correctly, you will of course get the points. So let us go to the board now. So the problem z, let me write it here because we can fit it here. So z is given to be what? 3 plus I divided by 2 minus I, and here I have 2 plus I, and in the numerator of that one I have 3 minus I. Okay? So let me see if I am recording this. So I don't want to solve this and this separately, even though that is also correct. I want to take the common denominator. Okay, so what is the common denominator here? 2 minus I times 2 plus I is the common denominator between these two fractions. Then I compare this common denominator with the denominator of the first one. I can see this is the extra factor. This extra factor should be multiplied into the numerator of the same fraction. So this becomes 2 plus I multiplied by 3 plus I. Okay, and then I have plus. I will do the same. I compare this common denominator with the denominator of the second one. I realize this is the extra factor. This extra factor should be multiplied here. So this becomes 2 minus I, and then I have 3 minus I. And then you can see this is extremely simple now. I have a multiplication here, a multiplication here, a multiplication there. Okay, so let us do that. I multiply 2 by 3, 6, plus 2i, plus 3i, plus I squared, plus, I multiply 2 there, it becomes 6 minus 2i minus 3i, and then plus I squared. In the denominator, I can also multiply, but always it is good to remember this is the conjugate pattern. But if you multiply, it works fine. So this becomes the first one squared, the first one squared, which is 4, minus the second one squared. Okay, now let us simplify. Plus 2i minus 2i are gone. Plus 3i minus 3i are gone. 6 plus 6 is what? 12. Yes? But I squared is what? Minus 1. I squared is what? Minus 1. Divided by? I squared is minus 1. So it becomes plus 5. So the answer is what? The answer is 10 over 5 which is just 2. Yes? But what is the question? The question is asking you about the imaginary part of z. So there is no imaginary part left, yes? Because 2 is 2 plus 0i. There is no I. So the imaginary part, as the question is asking, is just simply 0. Okay? But you have to write the solution. Okay? I have mentioned that if you just type, you will not get any points. You have to write the solution. Understandable? So that was also not hard, yes? These are supposed to be a little bit harder questions, but they're also simple. So, question number 7. If x minus a is a factor of this polynomial, we want to find a. We can solve this problem in 2 different ways. A longer method or a little bit shorter method. I will solve both of them here for you so that it's good to know about them, okay? So the goal is what? I want to fine-tune this a so that x minus a, with that a that I will find, becomes a factor of this expression. 2x cubed minus 5a x squared plus 4a squared x and minus 8. Okay, so the question is clear. I want to know what a should be so that this expression is a factor of this expression. What does it mean? It means this is divisible by that. Yes, that's it. So one way is to do the long division and find the remainder, but put the remainder equal to 0 because you want to force this be divisible by that. This is not creative way of doing it, but it works and it is not hard. Let us do that. So I will take 2x cubed minus 5ax squared plus 4a squared x minus 8. And I divide this by x minus a. It's a little bit, of course, harder than usual because you have to work a little bit with this. You have to work with algebra rather than adding the numbers because this a is with you until the end of the problem. Okay? So let me see if I have written everything right. Yes. So let us do the division. I take the first one divided by the first one, so it becomes 2x squared. I multiply this there and I change the signs. 2x squared times x is 2x cubed. I change the sign. I multiply 2x squared by minus a. It becomes minus 2ax squared, but I change the sign. But this is very simple now. You see, when I add them, even though the parameter is with you all the time, but adding these are simple. 2ax squared minus 5ax squared. It becomes minus 3ax squared. And then you bring down the other parts. And then repeat the process. So what do? You divide this by that. It becomes minus 3ax. Yes? And then you multiply it here. It becomes minus 3ax squared, but you have to change the sign. You multiply this by that, it becomes plus 3a squared x. But be careful, you have to change the sign. And then you add them up. So these two are gone. And again, even though a squared is with you, but adding is very simple because you have 4a squared x minus 3a squared x. If you add them up, it becomes 1a squared x, which is just a squared x. And then I bring minus 8 down. And I repeat the process. I take the first term I divide. A squared x divided by x is a squared. I multiply a squared there, it becomes a squared x, but I change the sign. I multiply a squared here, it becomes minus a cubed, but I'm supposed to change the sign. When I add them, this one and that one are gone, a to the power of 3 minus 8 is left. But the process ends here. Why? Because there is no x left. So this is my remainder. But I want to force the remainder to be 0. Why? Because I want this to be a factor. To be a factor means divisibility. So then it means that I will put this equal to 0 myself. a to the power of 3 is supposed to be 8. And there is one answer, not plus or minus. This is odd. So it is a equals to 2. So that is one possible way of solving this problem, which is not the best way, but it was not very hard. The best way is probably to do this. If you have a polynomial, okay, and you know that this polynomial is divisible by x minus, let me write alpha not to confuse this with that. So if you know this polynomial is divisible by x minus alpha, what does it mean? It means that if you do the long division process, what happens? You will continue. Let us say that I get the remainder r here, and I get the quotient q of x here. Okay. So if the remainder is 0, so let us say that the remainder becomes 0, it is divisible. Let me write it with r because it is good to know about generality. So I have a polynomial. I don't know anything about that. I divide it by x minus alpha for some alpha. Let us say that I do this long process and I get a number at the end, which I call it r. And then I get a quotient on top, which I don't know, I call it q of x. But I know one thing. I know that if I multiply this by the quotient and add the remainder to this, it becomes p of x. This is what we learned in the lesson. So p of x is what? X minus alpha multiplied by q of x plus r. Okay? Now, let me ask you something. It might seem a random calculation, but don't worry, just answer the question. If I ask you what is p of alpha, this is very simple to answer. Why? Because when I want to calculate p alpha, I have to replace x with alpha everywhere. So I replace this x with alpha, minus alpha. I replace this x with alpha, and then plus r. In r, there is no x, so it should be r again. But now, do I know q alpha? No, because I don't know q. But the good news is that I don't even need q alpha. Why? Because alpha minus alpha is 0. Regardless of the value of q alpha, 0 times q alpha is 0. 0 plus r becomes r. Yes? So this is a very important lesson. You can do it in the national exam as well. So if I give you a polynomial and I ask you to find the remainder of this polynomial by x minus alpha, one way is to do the long division and find r. Other way is to replace x with alpha. Okay? If you replace x in p with alpha, you get a number. That number is your remainder. It's much faster than doing the long division. Okay? So, if I ask you, what is the remainder of this by that, let me call this p of x. So do you remember, according to this that I told you now, if I want to find the remainder, one way was to do the long division and find the remainder. One way that we now learn here is to do what? Is to replace x with this number. It was alpha there. In this case, it is a. So r is nothing except p of a. What is p of a? P of a means replace every x with a. So let us do that. I replace x with a. It becomes 2a cubed. I replace x with a squared, a is a cubed minus 5a cubed. I replace x with a times a squared, a cubed, so 4a cubed, and then minus 8. But now look, 2a cubed plus 4a cubed is 6a cubed minus 5a cubed becomes a cubed. And there is a minus 8 there. So it is much faster. That is exactly the remainder. Okay, so if you want to find the remainder of a polynomial by a polynomial of degree 1, one way is to do the long division. The second way is to just replace the x in the polynomial with the root of your first degree polynomial. But it is a little bit faster, but it was not that hard even to do this. Okay, and then the next part of the story is because you want to have this as a factor, this means the remainder should be 0. Again, this means a is 2. So in any way that you solve it, either in this fast way or in this a little bit longer way, the answer is a equals to 2. Any questions? Okay. And then let us go to the next problem. Okay, might be the most trickiest problem was this question 8. First of all, this is 1.5. Remember that even in the national exam, you shouldn't be panicked. Even if you lose this 1.5 completely, you will still can get an A. Okay, but this problem, you can also get some points of it, I'm sure about it. So the question is this: if x and y are real numbers such that we know this is equal to that, then I am asking you to find the exact value of x squared plus y squared, again to the power of 2. Okay, so let me clean the board and write it on the board now. Okay, so even if you don't exactly know how to solve the problem, but you should be able to do at least something relevant to the problem. What do you think will be something relevant to the problem that might bring you some points even if you don't know how to solve the problem until the end? What? Yes, to do the division, at least because probably you somehow know from past experience that this is a division and you know what to do with division. If you do the division correctly, it will definitely bring you 0.5 at least. Okay, so let us do that. So 3 plus I, 1 plus 3I is equal to what? Is 3 plus I, you rescale it, you learned that before, okay? So what I do, I rescale it by the conjugate of the denominator. Do you agree? Okay, so I multiply the numerators. 3 times 1, 3 times minus 3i is 9i, I times 1, and this one is minus 3i squared. Okay, let me write it, minus 3i squared. And the denominator, even though you can multiply, let us not to do that, use the conjugate rule. The first one squared is 1, minus the second one squared is 9i squared. But you already know that in complex numbers, we have to change I squared to minus 1. So if I change I squared to minus 1, it becomes plus 3. Plus 3 is plus 6. Minus 9i plus I is minus 8i. Okay? And then what happens here? If I replace I squared with minus 1, it becomes plus 9, 1, 10. And let me simplify it by writing 6 to 10 minus 8 to 10 I. And if you simplify it, I would prefer to work with fractions, even though you can write 0.6. Let us work with fractions, because this becomes 3 over 5, and then it becomes minus 4 over 5i. So this will bring you definitely 0.5, because it is relevant to the problem. Okay, the next thing is that I go backward again. I have x plus yi equals to the square root of. Instead of the fraction below the square root, I can write this. Okay, this is the first relevant part, even if you don't know what you are supposed to do in the future, but you discovered the relevant part to it. What is the next relevant part, do you think? That shouldn't be still hard to guess the next step. The last step is a little bit creative, but not even this step. What do you think I will do now? Yes, we just raise to power 2. Yes, I raise the left hand side to power 2. I have to raise the right hand side to power 2. But that power 2 will kill this third sign. I will have this. Again, what is the next relevant calculation? Is to expand that. Yes. So the first one squared, 2 times the first one times the second one, plus the second one squared. But you know that I squared is minus 1, so this becomes minus y squared. So sorry, so if I raise it to power 2, it is y squared I squared. I squared is minus 1, so it becomes minus y squared. And then there is a dot here, okay? And then on the right hand side. Okay, but now I have a complex number on the left equal to a complex number on the right. We know the rule. The real parts should be the same, the imaginary parts should be the same. But there are two without I parts here. So that is in total my real part. So I combine them into one pair of brackets, and then this I have 2xy in another pair of brackets, it is not needed, times I equals to 3 over 5 minus 4 over 5i. Now you have to compare. Yes? The real part of this should match with the real part. And the imaginary part should match with the imaginary. So up to here, it will bring you 1 of 1.5, yes? 0.5, 0.5. But the last part of it is also 0.5. So even though this is a hard problem a little bit, but you still can get 1 point if you think logically. Okay, now look here. What I need is this combination. This might be a little bit tricky to see what is coming. Because if you don't see what is coming, you might start solving the system. It is impossible, in principle possible, you need to find x and y. And then when you found x and y, in principle it is possible because you have two unknowns, x and y, and you have two pieces of information. In principle it is possible, but then technically speaking it becomes hard. Okay, so do you have any idea how can I tackle this question mark without individually going and finding x and y? It depends, of course, how much you know about algebraic identities. Okay, so that is the creative part of it, only 0.5, okay? So what should I do? So let me ask you something. So here, if I ask you to calculate this, you have to have a little bit of experience, okay? If I ask you, do you know the answer to this? Okay, in principle, you can answer me now, yes? Do you know how to answer this question instead of the original question in the problem? Yes, because that number is 3 over 5, so instead of this, I put what? Yes, instead of this, I put 3 over 5, it is there. And instead of this, I put minus 4 over 5, and then I am supposed to add. Yes? This is a little bit tricky. You might say that, well, like, why are you calculating this? Because I have a little bit more experience. And it's not very hard, by the way. Can you calculate this number? This is 9 over 25. This is 16 over 25. But now look, if I insist you to do something with this one, what do? You raise it to power 2. The first one is squared, 2 times the first one times the second one. Yes, is minus 2x squared y squared. The second one is squared. And now if I ask you to raise it to power 2, you will answer 4x squared y squared. Yes? And then what is happening on the right? 9 plus 16, 25 over 25. Yes? But now look, this one and that one can be combined into 2x to the power of 4 plus 2x to power 2y squared, and then plus y to power 4 is equal to this number. But 25 over 25 is just simply 1. But can you tell me what is this? That is my question mark. X squared plus y squared to power 2. Why? Because the first one is squared. 2 times the first one times the second one plus the second one is squared. And that is exactly the question mark. Do you see? So the question mark is just 1. This is tricky. I'm not saying this is not tricky, but by the way, this is an A-level question. And then you lose 0.5 only not because of doing it. Okay, so that I just want you to know how to do the exam. When it comes to exam, there is one point. There's one goal. The goal is to collect as many points as you can. Okay? So you have to be a little bit a good politician when you are doing the exam. So you need to find a way to maximize your scores that you are collecting. Any questions? Okay. So let me stop here. Thank you.